Okay. Hi, Avian class. How's everybody doing? You enjoyed your snow days?
I don't entirely understand why Zoom classes have to be canceled because of weather. But here we are.
Yeah, it's a debatable practice, but I think the reason is a lot of community college students have young children, and if the public schools are closed, then they're going to have kids at home. All right. Glad to hear Tuesday wasn't bad. It didn't look bad from where I'm sitting. It was bad here, but we just got rain. All right, so this is basically last Thursday's PowerPoint, so you can notice that, no, I did update this. Okay, good. Yep, we will have a quiz posted tomorrow. These might be on Saturday this week. Those will be due, the quiz and the short answer questions will both be due on March 10th. Oh man, I would hate to have an exam canceled for snow, especially at the last minute.
Oh no, it wasn't even snow.
Yeah.
And like I was so prepared, and like it was just annoying. But like I did it today, and I'm happy with what I did. So I'm glad it's just. I would rather just get it over with for like. I don't know.
I understand that one. Your project topic and project format requests are due March 24th. So you've got a little bit time still to think about those. I'd recommend getting that in earlier so you have a little more time to work on it. Kinley, go ahead.
I already have what I want to work on. Can I just tell you now, or should I email that to you?
You should email me because I
Okay.
don't have my list open on the computer about the different topics.
I don't know if you saw my last. Oh, it's been a while, but last class we had, I had DM'd you think what I wanted to do it on, that were specify it. I don't know if you saw that, but I can also email you.
The best way to do it is to go on to Blackboard and submit it there.
Okay, I tried like looking at where you wanted to submit it, but I didn't see it.
Okay, it's probably, there should be a module for presentations and it's probably there. That's where I tend to put it.
Okay, I can check again.
All right, so last time we met, we were talking about vision. We were talking about the different ways birds use their senses compared to us and other mammals. So we went through a lot of information on vision. I've got just a couple of things still to finish up on this topic before we move on to hearing. So we talked about this when we looked at the videos, but I wanted to remind you guys that birds have the nictitating membrane, also called the third eyelid, and that is nictitating membrane. So this is a translucent, almost transparent membrane that can come across the eye when birds are flying in conditions like through tree branches, for example. But it's a way for them to basically blink without closing their eyes while they're flying. It's there to protect the eye during flight or to, as I said, to moisturize the eye. If they get a little piece of dirt or something in there, that third eyelid can close over, wash away whatever's on the surface there. And the bird doesn't completely lose its vision like it would if it did a blink where you close the first and second eyelids. Because the eyes are very large, but they're not round like ours, they're a slightly different shape. Remember, they're a little bit flatter front to back. They have limited ability to move the eye in the socket. So when we look over to the left or the right, we can keep our head still and move our eyelids, eyeballs. Birds can't do that. They have to move their head to see much of a range at all. But they do have some advantages. Bird eyes can move independently of each other. So, you know, if you look to the left, both of your eyes look to the left. With birds, they can look to the side with one eye, even though they can't move it very far, but they can move it with one eye at a time so that they can keep one eye on something and then look over here at something different. They can also hold their head still when they are moving. So when they are in flight, they can hold their head very, very, very steady, which allows them to maintain focus, especially when they're hunting. This is very, very valuable when they're hunting. So, okay. Let me see if this is looking. Okay. Notice this kingfisher's, this branch is moving, but he's keeping his head completely still because he's hunting for fish in the water below.
If you're trying to show us a video, we can't see it.
Okay. Thanks for letting me know that. Okay, hopefully you can see the video now. This is something that we certainly can't do, but I think it's really cool to watch birds do this.
It's a fun game you can play with chickens.
Oh, yeah, I believe that. It just looks like it's kind of teasing.
Yeah, it's pretty wild. And the last thing I want to say when we're talking about vision, I want to give you a specific example. This is an American kestrel. They're a relatively small hawk, well, bird of prey. They're not a hawk, they're a falcon. Very, very personable birds. I've worked with these guys in wildlife rehab, and they're just wonderful personalities. You know, you expect big personalities in big birds. No, the bigger predatory birds like red-tailed hawks, they're boring, not much personality at all. These guys have the personality. If this was sitting on the top of a power pole, this bird right here could see a cricket roughly this size. I made the cricket proportional on the ground. So try and imagine seeing something that much smaller than you while you're sitting on a power line. Really, really impressive vision. They can really see a long distance. Okay, so that's going to wrap up vision. Any questions before we move on to hearing? All right. So the primary sense that birds use is vision. That's the same as us. And just like us, the secondary sense that birds use is hearing. We use our hearing a lot as well. Their ears are much more similar to mammalian ears than their eyes are to mammalian eyes. Their range of hearing is smaller than the range of what humans can hear. So when we think about pitch or frequency, we can hear sounds that are lower in pitch, higher in pitch. Oh boy, that's squeaky. Than what birds hear. So their range is not as wide as ours. However, they are much more sensitive to tone, which is a reflection of quality and strength of the sound, and to rhythm than we are. Is there a cat playing in my background? Okay. I can hear a cat behind me and I see Kinley smiling at something, so.
I don't see a cat, but
Okay.
No, I just like the higher in pitch. It made me laugh.
oh,
It's hilarious.
Okay. The other thing is birds are better at differentiating between similar sounds than we are. So they can distinguish different individuals in a flock. So here is a flock of small parrots. Not quite sure which one this is. None of them are quite in focus. They might be cockatiels. But anyway, you can see this huge flock of these small parrots right here. They can detect the sound of individual voices in that flock. Even though everybody in the flock is probably calling out at the same time, they can keep track of who's around them, where their friends are, and all of that kind of information. This is a cassowary, and this is the outer ear opening of the cassowary. So they don't have a flap of tissue like we think of with our ears or with cat ears or dog ears. It's just an opening. And you can see a better look at that opening on this owl. You can see how large it is compared to the size of the eye here. Owls are more dependent on hearing than day active birds. So they have to have bigger ear openings, and they have asymmetrical ear openings. When I say asymmetrical, I mean that the left ear opening and the right ear opening are not at the same height on either side of the skull. One ear opening is lower down than the other one. This helps them to determine the direction of sound with a greater sense of accuracy than what we can tell. Our ears are symmetrical, they're the same size, they're at the same height off the ground. We have a limited ability to determine where a sound came from compared to owls. We also see very good hearing in insectivores. So birds that eat insectivores. So woodpeckers will sometimes tip their head when they're hanging on a tree. They're listening for wood-boring insects inside the tree. And that's where they're going to tap to try and get those wood-boring insects. You can also see this in American robins. They will tip their heads so that they can hear the sound of insects moving under the soil. So if there are insects right at the surface of this, right under the surface of the soil, they can hear them and then catch them. One thing that's very different with bird ears compared to mammal ears, especially human ears, humans lose our ability to hear certain sounds as we age. We lose the ability to hear higher pitched sounds starting about age 25. So much younger than you expect. The structures that are involved in hearing those high frequencies get damaged just from being exposed to those frequencies. Owls don't have this problem. They can regrow those structures. So they don't have problems with age-related hearing loss the way we do. That's basically hearing. Any questions on hearing before we go on? Okay.
I have a quick question.
Yes.
Do they use their inner ear for balance the way that we do?
I am 90% sure the answer is yes. Okay, sense of smell. So not that long ago, we used to believe that birds were not able to smell very well. It was believed that most birds could not smell things. But recent research has shown that birds have the same kinds of structures that we have in our nose, they have in their nose.
Sorry. I was away for a second. I see the wrong smell. One thing about hearing.
Yeah.
So in my other class, fundamentals of animal health, we're talking about ears in dogs, cats, but so how off, so like when birds can they get ear mites?
Oh, that's a really good question. I'm gonna
Because
assume,
a bird's ear is totally different from dogs and ours, but like if you gave it drops, like
I'm going to assume that that's a possibility, just like they get external parasites, just like dogs and cats get fleas, they get a type of mite.
yeah,
So I would be surprised if they didn't have ear mites.
cool.
They have one advantage over dogs and cats because the ear is open to the outside the way it is.
Yeah,
There's more, it's less likely to trap moisture
yeah,
and things
yeah,
like
exactly.
that.
Because I know dogs' ears like the pointy part, and then there's the ear that's like a golden retriever ear or spaniel ears, and they get caught on things. But like they can't get caught on things.
Well, yeah, they can't get caught on things, but also dogs with those floppy ears get more ear infections.
Yeah,
So and get more ear mites. So I think that this lack of having a structure covering the opening would reduce their risk of that being a problem.
okay, cool.
A lot of that was speculation.
Okay.
All right. But educated speculation. Okay, we were
I
talking.
always learned those were called swags, scientific wild ass guesses.
That made my day. So I'm gonna tell my mom. Hey, why would you learn? I find that acronym.
I am writing that one down because that is so good.
That is clever thing. WTF means Wednesday, Thursday, Friday.
Okay. Back to smelling. So I said we've got the right structures in the nose. We've also looked at electrical impulses in the brain while birds are being exposed to different odors. And we see brain activity in the area that we think corresponds to the olfactory area of mammal brains. So it makes sense that they have, they're getting a mental stimulus. When they're exposed to smell, they clearly can smell. If you find a baby bird on the ground and you pick it up and you put it back in its nest, the parents are not going to care that it smells like you. They're not going to abandon the baby, even though they can smell. So put the bird back if you can find the nest. If it's a fledgling, leave it alone. We'll get to that when we get to reproduction or wildlife rehab. All right, there are a few birds that are well known for their sense of smell. And so I put a couple images up here. This is a kiwi over on the right. The kiwi actually, I don't think you can see it on this picture. The nostrils are open way down here at the end of the beak. So you can see on the turkey vulture, the nostrils are up at the top of the beak, but on the kiwi, they're way down at the end because the kiwi eats earthworms and it finds them by smelling them. And they can get that beak well into the dirt to get that earthworm. Seabirds, a lot of gulls and albatross and various birds that live on and over the ocean can detect the smell of fish oils. They can detect the smell of squid and the smell of krill. Krill is a very small shrimp-like creature that is a very, very important part of the base of the food chain. It's what the baleen whales eat predominantly. So this makes sense. If you're flying over the ocean, you need to be able to find where your food is, and smell is a good way to find it from a distance, not just happen to fly over it. But that's also why birds gather around fishing vessels, because they smell all the fish that these vessels have caught, and they go, oh, there's food. I'm going to go find the food.
Another good point is sometimes when, I know this is totally, you mentioned the whale, so I was like, oh, but sometimes when there is shark attacking a certain, let's say, whale carcass or something, all these birds will gather around.
Yeah, it's not the shark that's attracting them, it's the whale carcass.
Yeah, well, I mean, yeah.
Yeah.
Oh, so yeah, well, I mean, like, yeah, but like that, it's,
Yeah,
I
they
think
can
you
find
heard in that picture that they will do that though.
Yep, absolutely. And then on the top here is our good friend, the turkey vulture. Turkey vultures also have a really good sense of smell. And they can detect decomposing food, decaying carcasses, roadkill, that kind of stuff. They do prefer fresher food, fresher carcasses, but they can find them with their sense of smell from circling way, way up in the air. That's really all I have to say about smell in birds. So the last sense we're going to talk about is magnetoreception. And this is really cool. This is a sense that we do not have. Magnetoreception is the ability to detect Earth's magnetic fields. We believe it's used for navigation. And this sense has been found in lots and lots of different animals, just not us. So it's been found in fishes, bats, box turtles, which means it's probably in other turtles, some insects, and bacteria. I don't know that it's been found in any mammals, but I've just never heard of it.
Well, you did just say bats.
I did say bats. Bats are mammals. You're right. Thanks for catching my mistake there. Okay. How magnetoreception works is poorly understood. There are two major ideas about how this works. One thing that we do know is that birds have an iron-containing molecule in their upper beaks. It appears that these molecules are capable of sending signals to the brain. And if you strap a magnet over that, so for example, you take a homing pigeon, strap a magnet up to its back or to its head, the homing pigeon can't find its way home. It gets lost. We think that this iron-containing molecule acts similar to a handheld compass, where it points north. So that's one thing that we think is involved in magnetoreception. The other one is really complicated, and there is a protein in the eye that seems to rely on quantum physics to detect magnetic fields. It is sensitive to weak magnetic fields, so it doesn't have to be a strong magnetic field, and it can be disturbed with radio frequency interference. It's probable that both of these different structures are important for long distance migration. The iron containing molecule probably is just north versus south, east-west kind of directions. And then the protein in the eye is probably fine-tuning the directions. So I'm not going to go into any more detail on how this works, in part because we don't want to talk about physics, much less quantum physics in this class. Except for Oneed, who wants to talk about quantum physics. Okay, so I mentioned homing pigeons. Homing pigeons are sometimes called carrier pigeons, male pigeons, messenger pigeons. They're all basically the same species. They're domestic pigeons that have been selectively bred for their ability to find their way home. Wild pigeons have an excellent ability to find their way home. Domestic pigeons have a great ability to find their way home, but we have selectively bred to improve that in these particular breeds of pigeon. The downside to messenger pigeons or homing pigeons, they will only carry messages one direction. They'll carry messages home. So if you want to send a message, you have to carry the pigeon with you and have it fly back home with the message. Now, this used to be very useful. We've seen evidence that male pigeons have been used as early as 3000 BC. So that's 5,000 years ago in the Middle East. They were used by the ancient Greeks, the ancient Romans, the Egyptians, the area that is now Iraq, and by the Mongols, which were even further east. So people would carry pigeons with them and be able to send messages back home. The Western world continued this process, and during World War I and World War II, we had war pigeons. It sounds more interesting than it is. Well, it is very interesting, but they're not actually, fighting the war. They're carrying messages. So troops that were on the move behind enemy lines, or spies that were behind enemy lines, or pilots would often carry pigeons with them, so they could be used to send messages back to the home base.
But
Back
how
to
much of that actually goes to that person? Like,
how much of that what?
could they really rely on the bird to give them to that that message to the person? Like,
Yes,
is it
they
that
really,
accurate?
really did. They really did.
That's actually interesting.
It was also used during the 1800s during the war. And once cameras were developed, they would fly pigeons with this little backpack with a camera on the breast. And so they would take it behind enemy lines and have the pigeon fly back. And when it got to the military base, which was home for it, they could develop the film and see where the enemy troops were located, where their bases were located, where they were hanging out and all that kind of stuff. This pigeon on the right is Cher Ami, a male pigeon, despite the fact that there's a woman named Cher. This is a male pigeon. His body is mounted and preserved and is at the Smithsonian Institution because of the fact that this bird was released from military troops who were pinned down between their military and the enemy's military. And so they were taking fire from both the enemy and their own military because nobody knew they were there. So they released the pigeon saying, look, we're stuck here in between these two armies. Quit firing at us. This bird took shots. It was shot. You can see one leg was shot out. It had other damage. I forget exactly the details of it. Got to the military base and was able to save all those soldiers' lives. So this particular one
I was just gonna say, yeah, it has one leg. Dino's behind it.
Yeah, it was shot off. Hi, my goodness, yes. Yes, my goodness. You can Google for more details on Cherami if you want. It's a cool story. Pigeons have been used in natural disasters. In 2002, yeah, that's right, 2002, the Pigeon Emergency Message Service was discontinued in Odisha, which is a state in India. So up until 2002, they had remote police departments would have pigeons that they could send out during natural disasters to get messages both back to their police department and then to other people who could possibly come for help. In 2002, they decided we can use the internet instead. Also in this century, Afghanistan rebels have been using pigeons to transfer messages behind the back of the Taliban. The Taliban has since banned pigeons. You're not allowed to keep pigeons in Afghanistan. They are being used to smuggle small items, SIM cards, phone batteries, drugs, both across international borders and into prisons. And then, I mean, this is just amazing what these little birds that everybody calls trash birds are used for. There was an April Fool's joke in 2001 called IP over avian carriers. IP is Internet Protocol. And the joke was that a pigeon could carry a large amount of data faster than the internet could. Specifically, this was targeting the internet in South Africa. And so in 2009, a South African IT company pitted their country's biggest internet provider against an 11-month-old pigeon carrying a 4-gigabyte memory stick.
Just for fun?
Yeah, for fun. So the pigeon including the time to upload the data, strap the memory stick to Winston's leg, and download the data at the destination, took an hour and 8 minutes. He flew 50 miles.
So back then they didn't have GPS satellites, right?
Back then, what?
Did they have GPS satellites?
Yeah.
So that's
2009.
how they approximately got that time frame.
No, I think they probably just called and said, we've let the bird go.
Okay.
You know, probably just did it over the phone. During that amount of time, the information that was being sent over the internet had only transferred 4% of the data. So the pigeon was faster. So I want to give you some homing pigeon records. The longest successful flight home was 1,100 miles. The average flying speed can be as high as 60 miles per hour. And racing pigeons, which are even faster, it's hard to say exactly where. I found different numbers on the internet ranging from 77 miles per hour to 100 miles per hour. 77, I believe. I think 100 is an exaggeration.
I was just gonna say that.
Yeah.
Sounds a little bit over,
How long
but
can they sustain the 60 mile per hour flying speed?
That's going to be a sprint. Yeah, so that's not going to be a very long distance. Probably, my guess would be that would be maybe 5 to 10 miles.
and when you say average, is that like a cruising speed? Or that like they're not diving down?
No, they're not
They're
diving.
not going up, but they're going straight.
They're going from a release site back to home.
Okay.
And a lot of times they beat the person who was releasing them home. So nowadays there are electronic timing rings. So this is a ring or a band on the bird's leg. And they have these electronic devices that will signal when they get home. So you know exactly when they got home.
It almost reminds me of like different trackers they use for
Hmm?
like fish species. 'Cause it's all computerized.
It's all computerized. Yep.
Yeah.
Okay. So that's bird census. Any questions on that?
Well, would you say pigeon has the best I like to call them specs out of any other bird for like their senses because of that.
No,
Like they were used to carry those messages or like,
I would say their homing ability is probably up there, but you've got to realize that we haven't tested every type of bird out there.
yeah. Do you think they will?
Huh?
Do you think they'll try to get to that?
No. 10,000 species? No.
I mean, I was like, I know the number's high, but like relatively like the falcons. Have they done it? They've probably done it because I know they've made videos of falcons diving. We saw one.
Right. Yeah.
And like the bigger birds, but like the smaller birds, we just guess, right?
A lot of times we don't even have guesses for that.
No.
Yeah.
Kind of surprised.
It costs money and takes time. Okay, so what I'm going to do now is I'm going to send you into breakout groups, and I would like for you to try and come up with a definition for intelligence. What is intelligence?
Can you repeat that again? Sorry, I heard intelligence.
What is intelligence? That's the question I want you to address.
Okay.
I'm gonna give you about 5 minutes in these breakout rooms. Okay, guys, I'm closing the room, so you have 1 minute to wrap everything up. Okay, so what is intelligence? Kinley.
So I said intelligence is usually the knowledge of, but in bird terms, I would say how the bird brain works.
Okay.
So I would think anyway.
Roni.
So we sort of came to the conclusion that there's a difference between what you know and how you use what you know, and that intelligence is more about how you use what you know and sort of synthesizing information.
I like that one. Yeah. Anybody else want to chime in? All right. So when we talk about intelligence, there is not a single clear definition that psychology and medicine and neurobiologists and animal behaviorists can all agree on. But most people are going similar to what Ronit was saying, the ability to learn and solve problems, the ability to reason and plan, creativity and critical thinking. So these are kind of the hallmarks of what we say is intelligence. But the definition is constantly changing. As we study animals and discover things that they can do that we consider intelligence in humans, well, there are people who feel threatened. And a lot of times they will move the goalpost, so to speak, and start adding things. So the best example is language. Do animals have language? Well, they communicate with each other. Kinley, go ahead.
I mean, I was about to say what you're just going to say. Yes, they do communicate with each other, but it's in a way for them to understand. So you could say that's a language.
Mm-hmm.
So,
Yep.
yeah.
Dr. Irene Pepperberg must be like their arch nemesis.
Oh, she is absolutely their arch nemesis. We are going to talk about her too.
I was gonna say, like, anything can be a language. Like even math is a language in its own way.
Yep. Yep.
Yeah, definitely birds have a language of their own,
Mm-hmm.
not as whatever the word, intelligible, whatever it is, it's not as easily, like, we don't know what they're saying as good as they do, because
Right. But does
it's the same.
that mean that it's not a language, or does it mean that we don't understand the language?
Well, no, because what if you're deaf? You can like, there's a language for deaf, like you couldn't have a language for people for deaf that are deaf, though. They don't have to hear things. They
That's
just
true.
have to like have different, like they have their hands.
Yep.
I saw a really wonderful tweet where someone was like, do you know elephants have a sound that means watch out, there are bees? And somebody else said, yeah, so do we. It goes, watch out, there are bees.
That's awesome.
Yeah. But what tends to happen is people go, well, they have ways of communicating, but we aren't going to call it a language unless they have sentences with certain rules for how the sentences are put together, yeah.
They have a
It's
couple,
more complex than it should be, though.
they have a couple languages like body language, vocal language, like
Sign language.
tone.
Yes,
There's more than one language.
yep,
There's a few languages all species communicate in.
yep, you're exactly right.
Like technological language, because like computers
Mhm,
use numbers in order to communicate.
mhm. And generally speaking, things that are instinctive behaviors are not generally considered signs of intelligence. But I'm not sure that that's a great idea either, because can you migrate to a specific location in Central America without a GPS? Never having been there before? Yeah. Lots of birds can do that. So we don't have a great definition. I mean, this class we do, but as a society, we don't really have that great of a definition. So can we measure intelligence if we don't have a definition? Can we measure it even if we do agree on a definition?
To a certain standard.
There are standardized tests that are available. But what does a standardized test measure?
So let's say you have a learning.
Your ability to sit there and fill in bubbles.
Thank you. Thank you. That's exactly where I was wanting to go with that. Yes, it is testing the ability to take a test. Okay, so there's a comment in the chat about elephants using the honey guide bird. Yes, I'm not sure I'm a little confused about how elephants would utilize this, but the honey guide bird does lead honey badgers and humans to bee nests. All right. So I don't believe that standardized tests measure intelligence. And there are a lot of free online tests you can take to get an IQ number. Yeah. No, that has nothing to do with anything. So we don't have a great way to test it in people. So instead of trying to get intelligence measured and like an IQ measured in animals, we're going to be looking at specific skills. Somebody got an IQ test at a hospital. Okay, yep. They certainly do that sometimes. When I was young, they did it in schools. Kinley.
Have you ever heard the quote, if you ask a fish to climb a tree, they'd spend their whole life thinking that they're different? It's kind of like, that's the whole IQ test thing.
Yeah.
You can't I don't think there is any quantity of measuring any intelligence.
I feel like
They're
I'm
just different
bad
types.
I had an IQ test at a hospital as a kid
Mhm.
because I have autism. So the IQ test took the whole entire day from early in the morning till dinner time. They literally go through everything.
Okay, that was intense.
Yeah, it was really intense.
I feel like I've had similar tests where like it's multiple days.
Yeah,
Yeah.
it's not multiple days, but it's a whole entire day. They literally had to check everything to make sure to see what I like had. So they had to do an IQ test, and they said I have a very high IQ.
Yep. Yeah. They make them complicated to try and be more accurate. I don't know how accurate those are. I think Kinley was saying there are different types of intelligence.
Yeah, I know there are different types of intelligence. I'm just saying there is an actual IQ test. And they ask you different things too. It's not all just knowledge. They
Mhm.
ask you like your interests, what you do, like all kinds of stuff.
That's interesting.
Part of it is creativity too.
Yeah.
Yeah, they do creativity tests too.
Yep. Okay. So when we're talking about looking at intelligences in animals, we can't necessarily do a single test that would work for all different kinds of animals. And it can be difficult to determine the difference between an inborn instinct and the ability to learn or solve problems. So flight is pretty instinctive in birds, but you got to admit, it's pretty impressive skill. So they do have to practice, but they don't necessarily learn that. And as has been pointed out, animals may be intelligent for their particular lifestyle. And it may not be the same skills that we perceive as intelligence in humans. And I've got an interesting example here, which is pointing. Pointing at things. Pointing. In humans, babies start to understand pointing between 9 and 12 months of age. Dogs understand pointing between 2 and 4 months of age. Chimpanzees never learn pointing. You can try your hardest to teach a chimp that when you point to something, that's telling him where the food is, and the chimp is never going to understand that. The other interesting tidbit here is Asian elephants, absolutely no clue about pointing. But if their mahout, if their person says, pick that up and points to something on the ground, they'll pick it up. But if you try and test them for their ability to understand pointing, they fail abysmally. African elephants, on the other hand, understand pointing. So it's not clear that who is going to understand this particular way of communicating. It clearly does not necessarily go with what we would call intelligence.
How do you test their understanding of intelligence if it's not pointing at something and saying, pick it up?
Well, there are lots and lots of different types of tests that you can do. So I'm trying to think of the other tests that we did. We'll talk about different tests that we do on birds that I can give you good examples of. I only know a couple of tests that have been done on elephants to try and get a judge of their intelligence. Communication is often a big problem. Speaking works with people, Speaking works with dogs. Dogs understand human language much better than most animals. But, and again, this was mentioned already, other animals communicate visually, by touch, by smell, ways that we don't understand or we aren't able to communicate. So that's a barrier right there. Some animals won't participate, and this can be individuals or species-wise. And figuring out how to construct the tests can be a huge challenge, because you need to say, okay, we are looking for this particular skill, and then figure out how to construct, how to organize a test that tests that particular skill. And if you're looking at elephants, something that the elephants aren't going to be able to destroy. In mammals, we've done a lot of work in mammals, and we can estimate a species intelligence by looking at two major things. One is brain size compared to body size. So not just who has the biggest physical brain, but compared to their actual body size, who has the biggest brain. And then the number of folds on the surface. So you see these grooves and folds on the surface of the brain. That is very, very important in a mammalian brain. It creates a larger surface area, and that is important because the neurons, the actual cells that do the thinking, are based on the surface of the brain. So the more surface you have, the more neurons you can have. You look at this marmoset here, that's pretty smooth. There's not a lot of folds. Just looking at that smoothness, I would say not that intelligent, relatively speaking. And marmosets are tiny. So that's probably big for the size of the marmoset. So we're like, okay, so let's do this comparison in birds. Right off the bat, we have one big problem. Bird brains don't have grooves on the surface. No folds there. We can use the general brain size to body size as a way to estimate intelligence, but it's useful not in comparing birds to mammals, but in comparing birds to other birds. Because in general, bird brains are larger than similar sized mammals.
I see they have a pituitary gland. Are they very hormone driven?
Probably about as much as we are.
Yeah.
If you know much about the endocrine system, you know it's kind of like it's a major.
Yeah, it's a
driver of-
major.
Yeah.
Yeah. See the pituitary gland.
Yep. The pituitary is very important. Yeah, exactly. So when we talk about bird brain size to body size ratios, the brains of corvids, that's the crows and the ravens, and parrots is similar to that seen in the so-called higher primates and the great apes, which would include us. So they have massively big brains for their body size. They also have, I thought it was, am I one slide behind where I'm supposed to be? Yeah, okay. Bird brains also have their neurons are much denser in their brain than ours are. So they have a lot more neurons in the same amount of space where we would only have, say, a few neurons. So we can see that This is a bar graph kind of showing the density of those neurons in a specific part of the brain. Specifically the forebrain. And the forebrain is the part of the brain, literally it's in the front, and it's where we do our reasoning and a lot of our thinking, our understanding, our decision making. A lot of that stuff is right up here in the front. Other birds, small brain to body size ratio. Anybody want to guess what group? What's my favorite group of dumb birds?
Waterfowl.
The ray
Oh,
types.
no, ray tights.
The ray tights, yes. Yeah, they have a small brain. They're not known for their intelligence. Okay. And the way the brain is set up, what we call the architecture of the brain, the way it's structured, the way it's organized, is very different in birds and in mammals. And that makes it really hard to figure out, to do direct comparisons between birds and mammals. So in mammals, we talked about the frontal part of the brain. At the very front of the frontal part of the brain is what's called the prefrontal cortex. That's the very, very front, just the surface right there in the front of the brain. That is very important for complex behaviors, for social behaviors, for understanding the consequences of our actions, and for self-discipline. In humans, this doesn't develop fully until age 25. We have found an area of the brain in birds that seems to have the same types of functions, but it's tucked back here at the back of the cerebrum here. So it's way, way back here in the brain. It's not right up in the front like ours is. And of course, we can't just say bird intelligence because birds have different amounts of intelligence. Yeah, and behavior patterns. So when we talk about the smart birds, I've already mentioned it, the corvids here, the parrots, the kestrel is smart. Not all birds of prey are smart. Some of them are pretty dumb. And the less smart ones, so even some of the pigeons, like the cockatiel, is put on the less smart side of the line there. Finches, sparrows, the kakapo, which is a parrot, they're hysterical. They're just hysterical.
I know some conures that are assholes. Okay.
Yeah, a lot of conures can be assholes.
Yeah, you know, I just found that whole. I'm like, I really want to move that picture just to the right. For what? Yeah.
Yeah, I would argue that cockatoos, I don't know that they're assholes, but they're very, very difficult to deal with. Crows are definitely assholes. Gulls are definitely assholes. Geese can definitely be assholes.
Oh, definitely.
Yeah.
See, and my experience is that I wouldn't have put owls up in the smart.
I wouldn't have either personally, but I didn't make this graphic.
Crow can be an asshole.
Hmm?
So it could go either way. Crow can be an asshole, but also smart.
Yes.
And then nice. Conyour's more an asshole, but nice.
Yeah, I would probably not have put conure this far to the nice side. But that may be, when we get to talking about parrots specifically and behavior in birds, we'll see that a lot of problems that people have with parrots as pets is because people don't understand their needs and don't give them
Oh yeah, no, I definitely agree.
the mental and physical stimulus and the behavior that they need.
Nope, I definitely agree on that.
Yeah. You guys have taken dog training. Same thing with dogs. Dogs that are assholes, it's usually because they're not getting enough attention, not getting enough exercise, not getting enough mental stimulation. All right. So I think this is a good place to stop. We'll go on and talk about some of the things that are associated with higher intelligence as far as social and environmental factors. And then we'll talk about some of the tests that we do in birds to try and figure out how smart they are and what kind of skills they have. There is a link in Blackboard for the bird brain video. I had not watched that one before. It's a good video, and it will give you a nice little glimpse at some of the different kinds of tests that we're going to be talking about. I've got a few things that they don't have, and they have a few things that I don't have in my notes. So, all right. If there are no other questions, I will see you guys next time.
Can I share my favorite animal intelligence test
Yes.
story? It's not bird, but there was a sort of a mirror test that they set up for some lions, where they had a wall of a mirror and a chain link fence that went right up to the mirror that bisected it. And on the other side of the fence, they had the keeper in like a clear box so that they couldn't smell him, but they could just see him. And they let the lions in on the other side. And the question was, could they look in the mirror and figure out that they needed to walk around the fence? So it was a solid fence with a little chain link section
Okay.
abutting the mirror. So they wanted to know whether they could look in the mirror and go, I need to turn around and walk around.
Okay.
All of the females immediately got it. And the males were like, gotta deal with this male in my space.
I feel like that's most males, not just tigers. Oh,
I thought
Yeah,
it was
that's a good one.
beautiful.
Yeah. Yeah.
Yeah.
We could have a whole discussion about the mirror test and why it's bullshit, but
Well, so that's why I liked that one, because it wasn't like, can you recognize yourself? It was
Right.
more like, can you recognize what it's telling you about your environment?
yeah, that's better than the self-recognition ones.
Yeah.
Okay,
okay.
great.